Hi everyone. In this video, we are learning how to balance redox equations in the acidic medium and then how to write the overall equation. So I thought of taking the examples from past papers itself. So we'll solve three examples, three equations as in the past paper. So see in this question, uh, the two reactants are SN2 plus and K2Cr2O7. So reaction is between these two. K2Cr2O7 में potassium is a spectator ion. So you may take this as Cr2O7 2 minus as the ion which is actually getting reduced or oxidizing in SN2 plus. So reaction between SN2 plus and Cr2O7 2 minus. Potassium is a spectator ion. And since they were take K2, there are two potassium, I took the charge of the anion as 2 minus. Okay. So now they're saying that first, oxidation half equation. So Sn2 plus is becoming Sn4 plus. So which is getting oxidized because oxidation state is increasing from +2 to +4. So that's pretty easy. That's in the neutral medium. So Sn2 plus will become Sn4 plus. For 2 plus 2, 4 plus, it has to lose two more electrons. It has already lost two electrons, two more electrons. So this is the equation for tin getting oxidized, losing electrons from Sn2 plus to Sn4 plus. For the other one, the Cr2O7 2 minus, this is getting reduced obviously because if Sn2 plus is getting oxidized, this will get reduced. Now, what will this form when this is getting reduced? They're asking you to check the section 24, which has all the reduction reactions from the reduction electrode potential. So, usme when you see the Cr2O7 2 minus is becoming Cr3 plus. You see the data booklet, it will form that. But you can take the ready-made reaction also. In fact, here they are asking you to take the ready-made half equation from section 24 and they are only giving you 1 mark because you're choosing the right equation. Now this is getting reduced. So in the data booklet, you will take the forward reaction because in the data booklet, all the forward reactions are reduction. But we're not taking the ready-made reaction, we'll develop or build up the reaction. So the reaction is Cr2O7, the half equation, and this is becoming Cr3 plus. And this is in the acidic medium. Say the acidic. So now let's first list down the stepwise how do you balance. So first you balance the species that gets oxidized or reduced. Balance the species that gets oxidized or reduced. Matlab here chromium. In short, except oxygen and hydrogen. Others basically. When I'm in the step 1, first balance the species that is getting oxidized or reduced. So in this one it is chromium. So Cr2 hai. So I will put 2 here. Second balancing is electrons. How do you balance the electrons basically? Electron balancing matlab you need to figure out that find out like how many electrons are lost or gained in this. Okay. So if we know that this is getting reduced, which means this is gaining electrons. So in this case, we need to find out how many electrons are gained. Now, how do you find that out? How do you find out that how many electrons are lost or gained? Check the oxidation state of the or oxidation number of that atom on both the sides. So chromium here is +6 and here is +3. So it's going from +6 to +3, which means it is decreasing. So we were right about that it is getting reduced. And because it's dropping from +6 to +3, this is gaining 3 electrons. But don't forget to multiply by number of atoms. Like gaining 3 electrons is per chromium atoms. But there are 2 chromium atoms. Remember that. Each chromium atom ka oxidation state is +6. And each chromium atom ka oxidation state becomes +3. But there are 2 chromium atoms. Each one going from +6 to +3. Which means each gaining 3 electrons. So total 6 electrons gained. So I will write 6 electrons again. Okay. Out of the 6 electrons here gained, each chromium will take 3 electrons. So there are 2 Cr6 plus, Cr6 plus. This gains 3 electrons. This gains 3 electrons. So total 6 electrons gained. So this becomes Cr3 plus. This becomes Cr3 plus. So that's 2 Cr3 plus. Okay. So that's how you think. Find from the oxidation number change, like how much ever is the oxidation number changing. From that, you can find out how many electrons are gained or lost. But that is per atom. So you need to multiply those number of electrons by the number of atoms that we did here. Okay, now this was the most important thing that done. So step 1 and step 2 may the most important things you have already balanced. Step 3 may then you balance oxygen. To balance oxygen, you add water molecules on the oxygen deficient side. I repeat, to balance oxygen, you add water molecules on the oxygen deficient side. So this side has 7 oxygen, this side has no oxygen, which means the right hand side is deficient by 7 oxygen. I will add 7 water molecules. Fourth and the last is balance hydrogen. So to balance hydrogen, you add H plus ions. I repeat, to balance hydrogen, you add H plus ions and not the hydrogen molecules, H plus ions, because it's acidic medium. Okay. Add H plus ions on the hydrogen deficient side. So here there are 14 hydrogen atoms. So I will add 14 H plus ions. Okay. And that's it. So remember the order to balance. First, balance the species that is getting oxidized or reduced. So in this case, it's chromium. Then check the electrons, how many electrons it is losing and gaining or gaining. That you can find out from the difference in the or change in the oxidation number multiplied by the number of atoms. Okay, here the change in the oxidation number was 3 multiplied by 2 atoms, so total 6. So 6 electrons are gained. So this is done, this is done. Now balance oxygen by adding water. And fourth, balance hydrogen by adding H plus. Okay, that's all. This is it. Now the same thing we will do for the other 2 examples. Yeah. So इसमें the reaction is between S2O3, which is thiosulfate, and Fe3 plus. S2O3 gets oxidized to SO2, Fe3 plus gets oxidized to Fe2 plus. Okay. So oxidation half equation में I'm talking about this to this, and reduction half equation में this to this. This reduction half equation is pretty easy. Fe3 plus is becoming Fe2 plus, which means it is getting reduced. So plus 3 to plus 2 matlab decrease. So reduce matlab it is gaining electron and it is gaining 1 electron because the decreases by it is reducing by 1. So that's done. Oxidation may H2O3 to SO2. So as we did earlier, S2O3 2 minus becomes SO2. Now the sequence or the order of balancing. First, balance the atom which is getting oxidized or reduced. So here obviously it is sulfur. So remember that the one who gets oxidized or reduced is always excluding hydrogen and oxygen, anything else. So sulfur अगर है तो 2 sulfur से इधर. So I will write 2 here. That's done. Next is electrons. How many electrons lost or gained? This is oxidized, which means this is losing electrons. But how many? For that, you check the oxidation number, change in the oxidation number on both the sides. So S2O3 may, this is minus 6 and this is minus 2, which means this is plus 4. So each one is plus 2. So each sulfur is plus 2. And on the right hand side, it becomes plus 4, which means each sulfur is increasing by 2. So each sulfur is losing 2 electrons. And there are 2 sulfurs, so into 2, which means total 4 electrons lost. So 4 electrons lost, I will write on the right hand side. Electrons gained should be written on the left hand side. Electron lost should be written on the right hand side. Okay, so this is main thing is done. Just balancing oxygen and hydrogen. So oxygen left hand side में there are 3, right hand side में there are 4. So left hand side is deficient by 1 water, so 1 oxygen. So I will write H2O. 1 oxygen, so H2O. And there are two hydrogens here. So this will be 2H plus. Okay. So that's it. The third example is okay. This is the third example where bromate 5 ions are acting as oxidizing agent to that means they are getting reduced to bromide ions. Now bromate 5 ions ka the formula would be given in the question. So we'll move up to see the formula. So BrO3 minus. That's a bromate ion. So deduce the half equation for this reduction reaction. So again the same thing. BrO3 minus is becoming Br minus. Okay. Balancing. First, the atom that gets oxidized or reduced. So here it is bromine, which is already balanced. One bromine here, one bromine here. So nothing to be done here. Next is electrons. So how many electrons? This is getting reduced, which means this will gain electrons. So how many electrons is gain? That you figure out from the change in the oxidation number. So bromate here is plus 5 because O3 is minus 6 and total is minus 1. So plus 5. And this is minus 1, which means it is going from plus 5 to minus 1. So there is a drop by 6, which means this is gaining 6 electrons. So gaining 6 electrons. Okay. So once the step 2 is done, then step 3 is oxygen. O3 hai, 3 oxygen hai to 3 water molecules and 6 hydrogen hai. So 6 H plus. Right? Okay. Now overall reaction ke liye, redox se matlab overall reaction. So when this is getting reduced, it is oxidizing Fe2 plus to Fe3 plus. So overall reaction ke liye, I will need to write the other half also, like oxidation half equation. Fe2 plus is forming Fe3 plus by losing 1 electron. Now to write the overall equation, you need to balance the electrons. So number of electrons lost and number of electrons gained should be equal. Because that's what the redox means, that electrons are lost by someone and gained by someone. So whatever number of electrons are lost by Fe2 plus has to be gained by bromate, and vice versa. Whatever electrons gained by bromate, all should be lost by Fe2 plus. So to equalize the electron, I need to multiply this because this is 6 electrons, this is 1 electron. I will multiply this by 6. Now the electron should get cancelled. Remember that in the overall equation, electron should not appear. So now write down whatever is remaining now. Okay. So that's how you like this plus this plus this is equal to this plus this plus this. Okay, that's the overall equation. Same thing you do for the other one. Yeah, here also. So then, yeah, that's all. So you may solve few equations from the past papers or from the book. And if you have any problems, if you're not getting the answers correct, let me know. Okay, that's all about the balancing redox equations. The understanding of balancing equations will also help you in one more thing, which is in the reactivity one, where you need to know the reactions at individual electrodes in the fuel cell. So you can see that here it's mentioned that fuel cell may you are expected to deduce the half equations for the electrodes reactions in the fuel cell, matlab the reaction at anode and reaction at cathode. And they clearly mentioned that hydrogen and methanol should be covered as the fuel cell, and proton member leave this. So half equations at hydrogen and oxygen fuel cell, hydrogen and methanol fuel cell. Now this is hydrogen fuel cell. These are the reactions that you need to mug up. So this is pretty okay. This you can manage. See, in both the hydrogen fuel cell and methanol fuel cell, the overall reaction, मतलब combined reaction of cathode and anode will be same as the combustion or burning of these substances. Like hydrogen burns, it reacts with oxygen. Methanol burns, it reacts with oxygen. Hydrogen burns to give water. Methanol burns to give carbon dioxide and water. So overall, anode and cathode ka reaction ka total should be this and this. So you can see that either it's the overall reaction is same. Individual reaction at electrodes. Now when hydrogen is getting oxidized and oxygen is getting reduced, so hydrogen will lose electrons because it's getting oxidized and it will become 2H plus. Okay. Now oxygen will get reduced, which means it will gain electrons. So suppose that oxygen has to gain electron. It will gain 4 electrons because each oxygen can gain 2 electrons and there are 2 oxygens. So that gives me O 2 minus. Okay, so that gives me 2 O2 minus. This is what I get. But if I have to balance overall equation, then I need to equalize the electrons. So this is 2, this is 4. So I need to multiply this by 2. So 2 and this becomes 4 H plus and this becomes 4 electrons. Okay. So just erase and both. 4 H plus and 4 electrons. So now if you see the 4 electrons get cancelled. And 4H plus 2O2 minus will give you combined, like they will combine to form 2H2. So 2H2 plus O2 gives 2H2O, 2H2 plus O2 gives 2H2. Basically, reaction at cathode, what they have done is that they have combined because final product is taken as water instead of taking O2 minus. So these, if I multiply this by 2, and this becomes 4 and this becomes 4, these 4H plus are also added as a reactants at the cathode. Okay, so instead of making 2O2 minus and then adding that to 4H plus, they have taken 4H plus here, right, in this and combined with the O2 minus and given the final product of H2. Okay, now methanol is important. Methanol ka reactions at individual electrodes. Either you can mug it up at cathode and anode, or you can also figure out. You can also figure out what is the overall reaction. See, for example, overall reaction I know is burning of methanol. So CH3OH plus O2. I'll just copy from here. 1.5 O2 gives carbon dioxide plus 2 O2. Now, how do I write the individual reactions at cathode and anode? So at anode and at cathode, anode pe oxidation takes place. And methanol is getting burned, methanol is getting oxidized to form carbon dioxide. So in the half equation, I'll only take this and this. So anode pe methanol becoming carbon dioxide. Okay. In the reduction, oxygen becomes water. Okay. Remember that the substance that is burning is getting oxidized to form carbon dioxide, oxygen getting reduced to form water. So these are the two half equations. So here, oxygen becoming water. Okay, now how to balance the equations the same way as we do usually. Here in the anode reaction, we first balance the number of atoms of the substance that we are getting oxidized, which is carbon here. So carbon is already balanced. It's one carbon here and one carbon here. Next is balancing electron. Matlab, if it's losing electron, then how many electrons it is losing? And gaining, then how many gaining? That depends on the change in the oxidation number. So carbon ka oxidation number here is H is plus 4 and this is minus 2. So carbon is minus 2. Carbon is minus 2 and here it is becoming plus 4, which means this oxidation number is increasing by 6, which means this is losing 6 electrons. I'm writing 6 electrons on the right hand side. Okay, so electrons done, then balancing oxygen and then hydrogen. So oxygen there are 2 oxygens here, there is 1 oxygen here. So left hand side is oxygen deficient. I will add water there. And now hydrogen total 3 plus 1 plus 2, 6 hydrogen hai. So 6H plus. Okay, this is how you balance it. So what I'm trying to say is that if you know how to balance the equations, redox equation, you don't need to mark this up. You can also figure this out. Oxygen in the cathode, the number of atoms of oxygen have to be balanced because that is getting reduced. So 2 here. Now how many electrons oxygen is gaining because it's getting reduced? So oxygen state is 0 here. It's minus 2. So from 0 it's going to minus 2, matlab it is gaining 2 electrons. And there are 2 oxygen atoms, matlab total 4 electrons gained. So plus 4 electrons. Okay, so oxygen is balanced, electrons are balanced, just the hydrogen needs to be balanced now. So hydrogen is plus 4H plus. Okay. Now if I have to write the overall equation, I need to equalize the electrons. 6 electrons lost, 4 electrons gained, not equal. So I need to multiply this by 1.5 because 1.5 times of 4 is 6. So this is 1.5, this is 6, this is 6, and this becomes 3. So now 6 electron cancel, 6H plus gets cancelled, and 1 water and 3 may say 1 water gets cancelled, 2 water remaining. So what is remaining here is 1 methanol, half, 1.5 oxygen, 1.5 oxygen, 1 carbon dioxide, 1 carbon dioxide, and 2 water, 2 water. So this is the way you can balance the equations in the fuel cell, hydrogen fuel cell and the methanol fuel cell. And these are the only 2 fuel cells that you're supposed to. Okay, so that's the end of this topic.